Hi, I'm Scott Thompson with Solid Concepts. We've been serving the rapid product development industry since 1991. We've mastered a complete set of rapid product development solutions that fall into four main categories: rapid prototyping, short-run production parts, tooling and production parts, 3D viewing software, and communication tools. Today we're at our newest facility, Troy, Michigan, just outside of Detroit. We're going to be talking about FRP, or fiberglass reinforced plastic, how to make these components, step by step.
The first step in the process is to analyze the client's geometry. When we receive the CAD data from the client, we bring it into our CNC room and put it into our CAD software. In this particular case, the client is looking for 25 plus parts for mold life, so we have determined that we're going to go with a longer life epoxy tooling as opposed to a CNC machined Ren layup tool. The second step in the process is to create the master model, or the master plug, so to speak. So what happens is, when the CAD guys have oriented the geometry, they create a drawing for a glue up. What we did is we selected 20-pound Ren board foam to create this master plug out of, because we only needed to pull one mold off of this. So our guys took the drawing supplied by the CAD department and glued up a rough frame of stock. Once that glue is set up and the block is dried and ready, it goes over to the CNC department. CNC department will deck the block, true the block, and set it up on the machine for milling. The machine then takes a computer program, mills all of the A-surface geometry and any other geometry that we added to it for the mold development. When it's done machining, it comes back onto the shop floor, where the guys then will take it, they will finish it, seal it with surface primer, finish off the primer. Once we have a good A-surface, then it will go into inspection. Once inspection's complete and we've verified overall dimensions, then it comes back out onto the floor for manufacture of the tool. We apply the green seal, the parting agent, and then begin to create the mold. What we're looking at now is the backside of the finished mold. After we have created the tooling face, or the epoxy face of the mold, we then come back and create a plywood egg crate structure. We take the egg crate structure and we epoxy it to the back side of the laminated face of the epoxy mold. What this does is give strength and body and rigidity to the epoxy mold, so that it has substance and body and will hold its dimensional stability. The first step in the process is to prepare the tool for part manufacture. What we do is apply a thin coat of parting agent. That parting agent is an alcohol-based parting agent, so it goes on as a very thin liquid. We'll give it about 5 to 10 to maybe 15 minutes drying time. The alcohol will evaporate out of it, and we'll soak up the excess. When the alcohol evaporates out of it, it creates a thin, almost invisible film. All you can see is a green hue to it, and that creates a parting between the surface of the mold and the surface of the part that we're going to manufacture. After the parting agent is dry, we then apply what we call a return flange. The purpose of this return flange is to create the end of part of the geometry. So when the guys are manufacturing the part, what they're going to do is apply the gel coat up underneath here. This does two things. It cuts out a considerable amount of labor for us in the trimming process, but at the same time it creates a beautiful flat line around here and gives us a nice even surface and makes a good part. If we did not have this, our material would come up and over, and the guys would have to grind this top surface down, and when they do that, we cannot control the waviness. So this little piece of return flange makes a big difference in the manufacture of the part. What the guys are doing now is applying the epoxy gel coat, or surface coat. This will essentially be the A surface of our manufactured part. We apply the gel coat so that we have a good, hard, rigid, smooth finish for surfacing the part. If we were to not apply this gel coat, it would literally be putting cloth right down onto the raw mold. And when we pop the part, we would have a very, very rough, unfinishable surface. So this epoxy gel coat creates a thin layer of epoxy that we can body out, sand, smooth off, and paint without having all of the texture from the fiberglass cloth. What the guys are doing now is applying the fiberglass cloth and beginning the lamination process. This process will be repeated several times till we reach the designed thickness of the part. So in essence, what they're doing is putting down a single layer of fiberglass cloth. When this layer is completed, they will again start the process over again, put another layer down, and repeat that process until 5 or 6 layers are down and the designed material thickness is achieved. The last step in the manufacturing process is the trim and finish. What Greg is doing right now is beginning the rough trimming of the part. So he's going around where we have excess material in using special tools to get rid of that excess material to make the final trimming process simpler and faster. The final trimming process will be done with 90 grinders and DAs. What we're looking at here is a completely trimmed and A-surface part. This part has been trimmed by Greg on the back side. It's been A-surface finished and it's been coated with automotive primer. It's now ready to go out the door for paint.
You just learned a little bit more about one of our many rapid product development solutions. If you'd like to learn more about alternative technologies, please visit our website at solidconcepts.com or call our toll-free number at 888-311-1017, extension 1 to talk to an experienced project engineer.